What's up, mathematicians? Welcome back to lesson number 5 on argument structures. This is lesson 5 in our unit on logic. In this video, we'll be looking at some more structures of arguments and talking about whether they are valid or invalid. So the first argument structure that we're going to talk about in this video is the hypothetical syllogism. You could also call this the transitive argument because it has this sort of transitive form, which you'll see very soon. But yeah, the sort of technical name for it, I guess, is the hypothetical syllogism. And let's look at an example of it to start off. So our first premise in this example will be that tomato implies berry. So you could say this as a conditional. If you have a tomato, then you have a berry. You could say it as like all tomatoes are berries. Either way, you can express with this sort of symbol of tomato implies berry. Okay, and then the second premise is that berry implies fruit. Okay, and what can we conclude from these two premises? Well, based on the hypothetical syllogism structure, we can conclude, therefore, that a tomato is a fruit, which some people take issue with because they think of a tomato as a vegetable. And nutritionists actually do consider tomatoes to be vegetables, but if you talk to a botanist, they will tell you, no, a tomato is a berry and a berry is a fruit. Therefore, a tomato is in fact a fruit. Okay, now this argument, if we break it down in a more sort of abstract symbolic structure, looks like this. Okay, so premise 1, you have A implies B. Premise 2, you have B implies C. And from these two, you can conclude that A implies C. Okay, and another example of that, based on the conditional that we've been talking about these last few lessons, would be this. In fact, I'm going to show you sort of a hybrid between the hypothetical syllogism and another argument structure as well. So consider this argument. Let's say premise number 1 is if you are in LA, then you are in California. We've been talking about this one a lot. Now let's add a second premise to that, that if you are in California, it implies that you are in the United States of America, because California is one of the states in the United States of America. And then let's add a third premise, that Lizette, I'll spell it correctly. In that last video, I realized I forgot the E on 2 separate occasions. So Lizette is in LA. Okay, and what can we conclude from these 3 premises? Well, we can conclude the following. We can conclude that Lizette is in the United States of America. Okay, so you can see the hypothetical syllogism show up here. LA implies California, California implies US. Therefore, LA implies US, but then we also have, in this particular argument, a single instance of someone in LA. So this argument is based on the hypothetical syllogism, but it also kind of has a modus ponens element to it too. So as we look at arguments, you'll realize that these different rules of inference, these structures, can be blended together in more complex arguments. And so when I look at this, I see, well, these first 2 here are sort of a, leading to a hypothetical syllogism. But then these last two here lead into sort of a modus ponens type of argument. And symbolically, we could write this out step by step as, premise 1, A implies B. Premise 2, B implies C. And if we're going to be really detailed about saying everything, every step, we could even add this third premise of A implies C. Okay, so this part here, this is a hypothetical syllogism. But now let's add another step. Step 4 is that A is true. And then we can conclude that C is also true. So we can recognize these steps here as corresponding with the modus ponens structure. Okay. Oh, and one other thing I do, want to make sure that we highlight before we go on to the next structure is that the hypothetical syllogism is valid. This is a valid argument. So let's go ahead and write this here. So we have a valid argument structure in the hypothetical syllogism. I'm not going to make you sort of guess, keep you waiting on this one. I'll just tell you as we go. Okay, so now let's move on to the next sort of argument structure. That's probably too specific of a way to phrase this one, but let's move on to it now. Okay, so the next type of argument I want to talk about here is called a false equivalence. And as you might guess, just from the name, a false equivalence is not valid. This is something that, if you see a false equivalence show up in a proof, you know that that proof is not valid. A classic example of this is, people will refer to comparing apples and oranges. So let's make an example based on that. So our first premise will be this. Apples, implies round fruit. Giving a lot of fruit examples here in this video. And then second premise will be oranges implies round fruit also. So apples implies round fruit, oranges implies round fruit. And if you're making a false equivalence, you might say, okay, well, that means, therefore, apples and oranges are equivalent. They're the same thing for the purposes of whatever situation you're looking at. So this is obviously not valid, right? Just because apples are round fruits and oranges are round fruits does not make apples and oranges the same thing. And one way to sort of understand this is with a Venn diagram. So let's go ahead and draw out a little Venn diagram here. So why is it that apples can imply round fruits and oranges can imply round fruits, but apples and oranges are not equivalent? Well, let's draw a little Venn diagram, and we'll say that this is the set of all round fruits, and within this set we can see, well, we have the set of apples, right? And then we also have the set of oranges. Okay, and sometimes there might be overlap between these two sets. In this case, there isn't. Apples and oranges are distinct, and there's no apples that are also oranges, no oranges that are also apples. But even in cases where there is some overlap, that doesn't mean there's equivalence. So just because apples and oranges are in this bigger category of round fruits does not make them equivalent. And that's pretty clear from the diagram here. Oh yeah, I should give sort of the symbolic representation here, or the abstract representation, more abstract. So premise 1 would be something like A implies C. premise 2, B implies C. And from that, we conclude that A is equivalent to B. So yeah, as I said already, not valid. This doesn't work, okay? And so one way that I like, one sort of diagram that I like to use sometimes with relation to this is you have some set A, and then you have some other set B, okay? And anything in A might imply that it's also in some other set C, right? And anything in B, you might be like, okay, that also implies some set C. So just because A leads to B and A leads to C and B leads to C does not mean that there's any connection necessarily between these two. There might be some connection. In this case, there is the connection that they're both fruits, but there's certainly not an implication that they are equivalent. However, if for some reason B and C were equivalent and A and C were equivalent, then you would be able to say that A and B are equivalent. So if, for example, you have an apple, if and only if you have a round fruit, if that were true, if all round fruits were apples and all apples were round fruits, and furthermore, all oranges were round fruits and all round fruits were oranges, so orange, if and only if round fruit, if those two things were both true, in other words, if these were both logically equivalent, then it is true that apples and oranges would be equivalent, okay? But it's only in the case where the equivalence goes in both directions for both of these premises. Okay, so there we go. That's what that would look like. And this is sort of a, you could call it a triangle or a circle. Like you can have even more things, right? You could make sort of a circle of equivalence if all of the things are logically equivalent. Okay, so one place where I've seen examples of this false equivalence type of argument show up is in these debates about gun control. And I'll give you an example of one that I've heard. And in this one, the first premise would go something like this. There might be an admission that, okay, guns do in fact kill people. Okay, but then the person may say, well, what about this second premise? That cars also kill people. Maybe I should put can. So guns can kill people and cars can kill people. Okay? So both of these statements are true, of course, right? Guns can kill people, cars can kill people. Now, but the issue is sometimes you'll hear it go to the next step of, okay, so if we're going to ban guns, then, I mean, are we also going to ban cars? Or if you're not going to ban something like a car, then you shouldn't be banning a gun because they're just both things that can kill people. This is a classic example of a logical equivalence, right? So just because guns can kill people and cars can kill people does not mean that you can establish a logical equivalence between the two, right? So guns, cars. So this is the jump that sometimes is made, that guns and cars are in some sense equivalent, and they're not, right? They're absolutely not. Guns and cars are designed to do very different things. Okay, so the next argument structure I'd like to talk about is called the disjunctive syllogism. What does that look like? Well, let's imagine a situation where I said, I can go to work. So I'll write it this way. I can get to work by driving or biking, okay? And when I say driving, I mean driving a car, and when I say biking, I mean biking on a bicycle. Okay, so let's say those are my two options. So that's the first premise. It's establishing some sort of or, this or that. The second premise would be saying not one of these things. So let's say I said, I did not bike. And what can I conclude from this? Therefore, we can conclude that I drove. Okay, this is a valid argument structure. This is valid. Let's go ahead and write that in here. And symbolically, we would write it as follows. We could write it as premise 1, A or B. We do have symbols we can use to represent or, but I'm just going to write or. It's a short enough word. And then premise number 2 is saying not A. You could do not A or not B, it doesn't matter. Not one of the premises. And then you can conclude, therefore, the other premise. So in this case, therefore, B. Now, one thing to keep in mind is that a disjunctive syllogism could have a bunch of things that you're comparing, that you're oring, if you will. So for example, it's not the case that the only ways I can get to work are by driving or biking. I could ride the bus. I could, take a ride share. I could walk. It would take me quite a while, but I could do it. And so there might be a whole bunch of things that were oring. And in that case, I would have to negate all of them except one in order to be able to conclude that that one is true. So for example, let's just add a third option here. I can get to work by driving or biking or taking the bus. And if I have those three options, I would have to eliminate two of them. I would just have to say something like, I did not take the bus, I did not bike, and then I could conclude, therefore, I drove. An example of that will show up and may have already shown up, depending on the approaches that you looked at towards the proof for the angle sum of a triangle, would be this. So let's write it out here. So premise number 1 would be angle sum of a triangle is greater than 180 degrees, less than 180 degrees, or equal to 180 degrees, right? So if we have a number and we said the angle sum of a triangle is equal to this number, that number logically, and you may say, well, I know what it is already, but we're not worrying about that right now. We're just thinking about logically. That number could be greater than 180 degrees, it could be less than 180 degrees, or it could be equal to 180 degrees. Now, if you could prove, let's say premise number 2, let's say you could prove that it was not greater than 180 degrees. And let's say premise number 3, you could also prove that it was not less than 180 degrees. Then you would be able to conclude, therefore, it equals 180 degrees. Okay, so this is using the disjunctive syllogism, but keeping in mind that since we have 3 possibilities, we need to eliminate 2 of them in order to be able to conclude the third. Okay, so just to wrap up, in this video we covered 3 argument structures or argument types. The first one, the hypothetical syllogism, is valid. After that, we talked about the false equivalence, which sometimes when people see this kind of logic, like what we use in the hypothetical syllogism, sometimes it leads people to start making false equivalences. And so we talked about the false equivalence and how that is not valid. And then finally, we talked here about the disjunctive syllogism, which is valid. And that will wrap up this video. As always, thank you so much for watching. If you learned something today, please do consider hitting the like button and subscribing, and we'll see you in the next video. Bye-bye.